Hello my dear students, today we are going to talk about row echelon form. In the last class we have already studied what is row echelon form. We have also seen few examples on it. In this class we are going to learn how to reduce a given matrix to a row echelon form by performing elementary row operation. So the thing is, whenever you are having some matrix, we can always convert that matrix to the echelon form by performing some elementary row operations on it. Now the question is how to do it. That is exactly what we are going to study today. So let us begin. In the last class we have already seen the definition of row echelon form. So these are the two conditions of a row echelon form. So the first condition is all the zero rows should be collected at bottom, and the second condition tells us that leading coefficient of each non-zero row should be on the right hand side of the leading coefficient of the previous row. And I have given you this note also, which we are going to use in future. So today's topic of discussion is this: reduction of matrix to its row echelon form by using elementary row operation. So there is a standard process that we are going to follow here. So let us learn what is that process. So as the first condition over here says that all the zero rows should be collected at bottom, so that is exactly what we are going to do. So if certain matrix is given to us, first of all we will shift all the zero rows of that matrix to the bottom, obviously if the matrix has zero rows. Sometimes it may happen that that matrix may not have zero rows, so in that case we will directly jump towards what? The second condition of row echelon form. Let me give you an example. So in this example you can see that zero row is there. So whenever you are having zero row in a matrix, just shift it to the bottom. That is our first step, which I will write here. And same operation I will perform on this matrix to shift that rows to the bottom. Can you guess which operation I should perform here? So I will say by R1 3, because I have to shift this first row to the third row position. So whatever matrix we will get, it will be 4 2 3 1 0 2 0 0 and 0. Now once we are done with this, we will move towards the second step, and the second step is to circle the leading coefficients. So now let us circle it. So what are the leading coefficients? 4 and 1 are the leading coefficients. Now once we circle the leading coefficients, our next step is to arrange these rows in appropriate order. Now why we are arranging the rows in appropriate order? Because appropriate order, you will understand what do I mean. Because the second condition says that the leading coefficient of each non-zero row should be on the right hand side of the leading coefficient of previous row. So what exactly we are going to do here is, once all the zero rows are shifted in the bottom, so we will shift our remaining rows in such a way that our leading coefficient should appear in this way. So star indicates the leading coefficient, you can say. So star here, star here, star here, yeah. So in this case my matrix is having how many rows? 1 2 3 4 5 and 6, let us say. So therefore there are 6 leading coefficients. It means that all the rows are non-zero. So this is the order in which we are supposed to arrange all these leading coefficients. And why we are doing it? Because according to the second condition of the echelon form, the leading coefficient of every non-zero row should be on the right hand side of the leading coefficient of previous row. Since our given matrix may not be in echelon form, so therefore we have to do these arrangements. Sometimes it may happen that, just this is one case that I have told you, in some cases you may get this structure also after rearrangement here, here, here and here. and we will have a 0 row at the bottom, let us say. Now in this case you can easily see that once we arrange our rows in this way, remember these are the leading coefficients, then one can easily see that this is already the echelon form. But this beautiful example may not be there always. So once we do the arrangements, we may get such cases also. So there may be some rows which has leading coefficient exactly below one below another, as shown here. Is that fine? Now how to tackle with this, that we are going to study later on. So the first step is to collect all the 0 rows at bottom, which we have already done in this example. Circle the leading coefficients, we have already done. And the third step is arrange. I hope now you understood what is the meaning of appropriate order. Yeah. Now let us discuss few examples on it, so the idea will be more clear. Yeah. Now in this second example, you can see all the 0 rows are already collected at bottom. Our second step was to circle the leading coefficient, and which already satisfies our order that we actually want over here as well, right? Because we are already having the leading coefficients one below another, as you can see here. Moving towards next example. In the third example, you can see that the 0 rows are collected at bottom. Let us circle the leading coefficient. Now you can see that whatever I have told here, this is not satisfied by this matrix. So we have to arrange it so that the leading coefficients are in this order. So which operation I will perform? I will interchange my first and second row. So this will be equivalent to 0, 2, 0, 0, 0, 0, 0, 5 and 0, 0, 0, 0. That's it. That is what we wanted. You can see here is the leading coefficient and this is the leading coefficient. If you want, you can keep it circled. Moving towards next one. Again here 0 rows are not collected at bottom. We can collect it. So after doing that, I think we will perform by R 2, 3. So whatever matrix we will get, it will be 0, 1, 0, 0, 0, 0, 2, 0, 0, 0, 0 and 0. Okay. And once I circle the leading coefficients, they are already in our required order. Moving towards next example, over here you can see that the matrix doesn't have 0 rows, so don't worry about the first condition. So we will directly move towards the second condition, second step I will say. Now in our procedure, that is nothing but circling the leading coefficients. Now once you circle the leading coefficients, I have to arrange it in appropriate order. You can see that over here the order is not appropriate because your leading coefficients are like this, which I don't want. So by doing some elementary row operations, I have to convert this order in this way. Yeah, this is possible, right? Just I have shifted this leading coefficient over here and this over here, right? So obviously we have to perform some elementary row operation in order to do it, and which operation I will perform by R 2, 3. So once I interchange it, what I will get 0, 1, 2, 5, 0, 4, 2, 1, 0, 0, 1, 0. Now you can see that our leading coefficients are in the required order. Yeah, and in the next examples you can see that 0 rows are not there and the leading coefficients are this. Over here also no 0 rows. So it already satisfies our 3 steps that I have told you. What about this example? So no 0 rows. So I will move towards the next step, that is circling the leading coefficients. Now they are in this order. Which one? like this and like this, which is not our standard order which I have told you. So I have to convert it actually somewhat like this order. So no problems with this 9, right? So just I need to interchange first two rows. Once I interchange it, ultimately you can see that I will get such an order of my leading coefficients. So this thing will come by practice. So you have to solve more and more examples to get a sense of it. So I will say by R12. So this will be equivalent to 2, 5, minus 1, 8, 0, 1, 10, 2, 0, 0, 9, 4. And you can see that that is what we wanted, right? Moving towards next example, no 0 rows, and the second step is to just circle the leading coefficients, and they are already in our required order. So that is what I meant by this third step in our procedure, that is arrange the rows in appropriate order. Now once you do it, we will focus on this note that I have given you.